Alright, this is number 6 in section 14.1, and the question is: a drug is injected into a patient's blood vessel. The function C equals F of x comma t represents the concentration of the drug at distance x millimeters in the direction of blood flow measured from the point of injection and at time t seconds since the injection. What are the units of the following derivatives? What are the practical interpretations? And what do you expect the signs to be? So C is concentration. And that would be, I'm not quite sure the units of it, but X is millimeters from injection, and T is seconds after the injection. So the concentration, I guess, would be units per liter, I'm gonna say. Alright, I might search that, but yeah, so it's gonna, I guess we'll say concentration is the units, because they didn't give us any. So it's asking, A is asking all of those questions. What are the units? What's the practical interpretation? And what do you expect the signs to be? For DC dt. So this is, the units are going to be concentration over millimeters from the injection point. And that will be for every 1 millimeter from the injection point, or how drastically the concentration changes for every 1 millimeter from the injection point. And so we can expect the concentration to decrease as the millimeters increase. So we're expecting the units to be negative, and the practical interpretation would be that you could be looking for how quickly a drug is being dispersed into the surrounding tissues and stuff. So that'd be important, how far away and how concentrated it is, the drug is after a certain number of millimeters away. And then B is dc over dt. So this would be concentration per second after the injection. And so as the seconds increase, the concentration will also increase. So we can expect this to be positive. The practical interpretation would be that that we have to understand that the concentration is going to increase for every 1 second that you wait and test again, I guess, when you after an injection, because you're injecting something and it's dispersing. So the concentration will increase, and yeah, the units are concentration per seconds away from the injection point. This is a pretty straightforward problem.